Okay, my talk is entitled How to Stay Strong with NgRx. Has anyone here heard of NgRx or used it? So quite a few of you heard it, that's good. So what I'm going to talk about is, for those who don't know what NgRx is, I'm going to give a lightning intro to NgRx, and it really is a really quick introduction, just so you know what I'm talking about. Then why would I do this to myself? NgRx adds a lot of work into the general workflow of how to get anything done. So here I explain why you would give yourself all this extra work. And then I'm going to talk about why strong typing. I think it's the only way to build big complex systems with any kind of JavaScript front-end toolkit. Then I'm going to show the minimum sample code to get a piece of NgRx running. It's generally the hello world most people look at. But then I'm going to look at how to make it stronger, how to introduce strong typing into that pattern. So let's start with what NgRx is. And NgRx is the implementation of the Redux pattern inside Angular. And here's something to get your head around. The Redux pattern is a way to implement a predictable state container for JavaScript apps. So what does that mean? Well, a state container is just holding your stuff, whatever you're working on. So if you're working on a contact form, it's the details inside the contact form. If you work on a shopping cart, it's the data you're holding in the shopping cart, what the user has picked, how many they've picked. So the idea of a predictable state container is that you only change that state in very narrow, predefined ways so that you've got more control over what's going on. And so the Redux pattern looks something like this. Everything that is the state lives in this thing called the store. That is the only place that state is in. So if it's your shopping cart, you would have a store for your shopping cart. You might have a store for the items in your shopping cart. When you're building the view of your application, it reads directly from the store. That's the only place anything you can see ever appears. So if I can get rid of this guy. So yeah, the only way the view gets information to display is from the store. The only way you ever change anything in the store is you dispatch an action. The action does its work and runs through something called a reducer. So a reducer is a function that receives an action, and it's only reducers that transform the state. So if I'm adding an item to the shopping cart, it'll be the reducer that adds an item to the shopping cart. I will drop and turn that off completely in a minute. So only reducers can change what's in the store. What that means is, if you want to do a really simple change, like increment a number, you've got to write at least 3 steps. You've got to write an action. You've got to write a reducer, and you've got to write the reducer to change the store. One of the key things with this pattern is that everything in the store is what's called immutable. It means you create an object, that object never changes. If you want to change the state, you replace the entire object. And we'll talk about some of the benefits of that. Thanks, Diego. A bit later. Don't make me turn it off. Okay, so why do we put ourselves through all this pain? Why are we following this really rigid pattern? And the answer really is to avoid something called spaghetti code. So in spaghetti code, the relations between the pieces of code are so tangled that it's nearly impossible to add or change something without unpredictably breaking something somewhere else. I think every single person in this room has at some point had a piece of code in front of them, and they're afraid to touch stuff because you never know what's going to blow up. Happens to everybody. And so this is why we do this stuff, is to kind of try to mitigate some of those problems. Now, in my opinion, you take spaghetti code and you put it through a blender. In this case, the blender in the torch analogy is Angular. You get something called mutable soup. So mutable soup, the concept here is, I've got this piece of state, and it's containing all the what's going on in some application, but I can change it anywhere and anywhere I like. Anything could happen. So at any point of time, I have no idea what the state could possibly be, and it's almost impossible to keep track of. So for me, the role of software architecture is to impose artificial constraints on your application in order to promote consistency and predictability. So the idea is, I could do anything. I'm going to choose not to do anything. I'm going to choose to work in this very predetermined manner in order to get some organization, get some structure to this chaos. So that's where the Redux pattern comes in. I'd say out of all the patterns I've used, the Redux is the most constraining I've ever worked with, but it also gives you some awesome features. One of those features, and I will demonstrate this on the I'm going to just do a quick demonstration of a demo app, if I can find it. It's here somewhere. There it loads. Okay, this is the example demo application available from NgRx. And I think I can just type test and test to log in. And like most examples, it's a bookstore. So let me do a few steps. I can find a book. Let's type test. And I've done a search for books. But what I've got in my tooling hanging off this whole system is I can come to here, take a look at the Redux Dev Tools, and I can see all about the various actions that have just been performed, and I can step back and forward through those actions. Because every single state change happens through this pattern, this tooling lets me step back and forward through that timeline and work out where something went wrong. So this is a huge, huge deal. So that's a good reason for using this pattern. Okay, well that's the Redux pattern. Let's talk a bit more about strong typing. So why am I obsessed with strong typing? And really, let's first consider where all my bugs come from. There they are. So this is me. My name is Brendan. I'm an SSW solution architect. Means I spent most of my time on client work, building applications. I first wrote JavaScript in 1999. I've been writing JavaScript ever since. Hopefully one day I won't have to write JavaScript anymore. I'm not a big fan, but it's still the one we've got. And there is a bit of a problem when you're trying to develop a complex system with JavaScript, and that is you can't polish a turd. JavaScript is a terrible language to work with, but you can roll it in glitter. And that's where TypeScript comes in. So why would you use TypeScript? TypeScript gives you all this awesome stuff, a bit more like C# or a bit like Java. It's got IntelliSense, not a completion, that works. It's got refactoring tools, so you can actually start changing things and have the system know you've changed it and then change it other places. You've got compile time checking. This protects you against yourself. You set up an object and you set up it's got these fields against it. If you use that object on another screen, you have to keep going between the two. The tooling will know you've made a mistake. The tooling will auto-complete things for you. And so it's just overall, I find with TypeScript you've got less bugs and it's a whole lot more productive. There is one thing not to forget though when you're using TypeScript, and that is everything that TypeScript is showing you is fake. At runtime, there is no types. At runtime, it is still running pure JavaScript. The only thing TypeScript gives you is type checking at compile time while you're working with it. That's not too bad though, because you still get a lot of tooling and you still get that compile time checking, so it's still worth doing. But never forget that at runtime, none of what you see is real. So let's take a look at some of the really simple example code of how we then go about writing some NgRx. And really what you need to write is a reducer and an action. Remember, the action is the thing you raise. I'm going to raise an action to make a change. The reducer is the function that you're going to run to actually perform that change. So we've got this interface here called reducer, and see straight away it's a reducer of type T. And we've got this thing called the state. So that object, whatever type it is going to be your shopping cart or your contact form, whatever you're working with. Though I probably wouldn't use this for a contact form, but it'd be an awesome, very big contact form. Then we look at the interface for an action. Pretty straightforward. We've got this action object here, and it's got two things, a type and a payload. So the type is how we determine what is the action I'm raising. Adds to my shopping cart action. And the payload is, okay, I'm going to add to the shopping cart. The payload is, I want to add this particular product to my shopping cart. So just those two things, type and payload, is all you ever need to do to make an action. But there's one thing on this screen that I really, really dislike. I'm not alone in this. And that is, this is great. Like I've got a state, and this has got a generic type. So when I create reducers, I will specify this is a reducer of a particular type of thing. When you look at action, this here, I have an optional payload of type any, which means I can put any old junk in there. I've got no control over what's going on. I'm not the only person who doesn't like this. I was doing some research and I found this, this post. Come back. There is quite a big discussion online about the fact that the interface action lets you put anything in there and doesn't let you specify a type. And I would love to see this come through and be the way forward in the future. So let's take a look at pretty much the simplest reducer you can possibly make. And what we're doing here is our state is a single number, and we've got two actions we're going to support. We're going to add to the number, and we're going to remove the number. So this is just stuff you could do with two one-line functions outside of NgRx. But this shows you how much boilerplate you have to put around NgRx. It's the minimum possible code you could write to make NgRx. So you see we've got these strings here, which are the types. We do the switch statement on the type, and we run through and actually perform a change on our state. Now, in this case, there's a few things I don't like here. First of all, these strings are just strings. There's a word for that in software. It's called a magic string. It's a string you've made over here, and then you've got a string you've made over here, and you're relying on them being typed the same by the developer in both cases for it to line up. So it's magic. I have to type the magic string decrement into this thing here in order to match this thing here. So one thing if all you do is don't use magic strings and declare these as constants, you've already made a big improvement. The other thing is here, this is how we raise an action. So we use a dispatch command, which is off the store object. And we say the most simplest action you can make is I've just created a complete anonymous object here and specified the type. That's fine, it works, but we've got no control, we've got no type safety. You could put any old junk in here, or you can just make stuff up and put it in here. And if you just happen to make up code that looks for the things with the names that line up, it'll work. It works fine. It's JavaScript. You can do anything you like. But we don't want that. We want the system to tell us when we've done something wrong. A good place to look when you're moving forward with NgRx is the example app. So this is the NgRx GitHub page. You've got this example app here. And what I've seen over time is the example app itself gets more and more type safe as they iterate through the versions. So early on you'd see some pretty rough looking reducers, but now you're seeing strongly typed actions being used. So let's take a look at what a strongly typed action looks like. So let's start with an action. So the very first thing we always do is we create a constant for every single action we're working with, so that we only ever refer to this name via this constant. So if anything changes, we'll get a break. The next thing we do is we create these classes. So for every single action we want to raise, we create a class. And then one of the main reasons we do that is we can then create this constructor. And this constructor has a public payload, and the payload is always typed. So in order to raise this action now, I can go new search student action, open the bracket, the tooling where I'm using it will know it's expecting a payload of type this search request. This particular example, I'm going to search for a student. I've got a very simple search request DTO. It's F12 on that. And you can see I'm searching for students across schools. I can specify a search text and the school under which I'm searching. Simple as that. So that's a strongly typed action. And you can see I'm exporting those out here. Let's take a look at how we use that action. So you've seen before, quite often you see a switch statement based on those particular actions. So the thing with reducers is all reducers in the system run every time there's an action. So what the reducer does is it chains up all these functions and it looks through and says, am I doing that action, am I doing that action, am I doing that action? And finally somewhere in the system it goes, that's the action I'm running, and then it will run something. Now what you typically see in the examples is you'll see a big reducer with a huge switch statement and loads of blocks of code to transform the state. So what I like to do is break that up a bit. I'd love to get rid of these completely and just use types, but what I tend to do is make a reducer that just calls other functions, and then each individual thing that performs an action is quite a small little function there, and that's sort of separate, and that can be tested individually using unit testing. Final thing I'm going to show you is a side effect. So if we go back to the, I'll go back to the original slide here. Okay, there's one extra kind of thing you can do hanging off the side of this, and that's something called an effect. So what you can do is when you raise an action, instead of that being picked up immediately by a reducer, you can have something called a side effect, because this whole thing is pretty self-contained. There's no room in here to go call out a call to an external web service, anything like that. Anything where you've got to go and do some long-running task, post to a server, read from a database, come back, and then run the reducer. Reducers are simple functions that don't have any dependencies anywhere else. They take in a piece of information, they transform the state, they update the store. So if you want to do a database call, I want to load the current state of my shopping cart, I'd raise an action, and that action would fire an effect. The effect would fire off and talk to the database, come back, and when that's finished, it fires another action to get picked up by the reducer. So in this case, the action would fire an effect, the effect goes up and fetches some data, that then raises a new action, generally this load was successful, and the payload at that point contains the data you've loaded from the database. Then that payload gets mapped by the reducer into the store, and all the view gets updated. So with that kind of background in place, I can come back to my effect. So here's an example of an effect. So I've got an action coming in, I've identified the type of the action. In this case, I call a switch map to grab the action out. And I've cast that action to its type. Unfortunately, I've not found better code to say, okay, I've already specified the type of the action once. I need to actually cast it again to get the type of the action. But what I'm very clear on what I'm doing here, I only ever get the type of the action because this is responding to the action. I never get manually the type of the payload. So the payload is the data attached to that action. I always rely on the tooling to tell me that. So because I've typed this to strongly typed, and because the student circs action has a certain type, I can come here and go action.payload, hover over that, and I can see it's of type this search request DTO. Which means if I go and completely change the code, that will get picked up and start highlighting red squigglies underneath. So I'm protecting, so the whole idea is I'm protecting myself from my future self. So I think that's enough code to show you. Let's move forward again. So in summary, how to stay strong. Oh, here we go. Always use strongly typed actions with typed payloads. Never create a on-the-fly action just by sending a string in. Always use that strongly typed and the typed payloads. Inside your actual things that respond to those actions, so inside your reducers, inside your effects, grab the action type because you know this is for that action. Never manually cast the payload type. Let the tooling tell you what the payload type is. So I specify one thing, the tooling knows everything else I need to know. There's some helpful methods that have been put into the system, and one of them is called toPayload. So inside your effect, you can go, okay, I've got an effect running. I'll call the toPayload function. It will give me what my payload is. Unfortunately, that particular function doesn't give you a typed response. So as soon as you use one of those functions that doesn't give you a typed response, you've lost your strong typing. At that point, what you're dealing with any, and it won't pick up if you've got the wrong name on a field. There's one thing you can do that's quite useful, and that's tslint. So tslint is an engine that lets you, on the fly, will scan your code in Visual Studio Code. And there is, let me open up a different one. So TS-lint that just specify all kinds of various rules to apply to your code base, and will highlight a little kind of error message if you break those rules. And that's configured in this little file here. And you've got all kinds of rules like max line lengths, how to do your camel casing, where your angle brackets are. And generally the rule of thumb I use with TS-lint is it's great to have some standards, it's great to agree on some standards, and if you check in your TS-lint rules, then everyone on the team will be writing to the same standards. But one badly worded, one badly named variable is worth about 1,000 TS-lint rules. Because the variable names you use is how you communicate what you're trying to do. It's all very well it being nicely formatted and passing all your tests. You pick one bad name, the next person that comes along won't be able to read it, won't understand what it is you're trying to do. But even with that caveat in place, there's lots of rules you can take. And this one, no any, means if you've used the any keyword and say the type of this thing is any, it will highlight a little squiggle underneath and say don't use the any keyword. Make sure all your things are strongly typed. And I think that's what I had to say. Shift F5, so thank you.